The multidisciplinary nature of engineering. We are going to explore how engineers collaborate with non-engineers in the designing and building of a hydroelectric dam to provide clean energy. According to a report by the U.S. National Renewable Energy Laboratory, engineers only play a very small role in the operation of hydroelectric dams. Only 9% of on-site hydropower jobs are in engineering services, and these roles can be further broken down into civil, mechanical, and electrical engineers, as well as drafters, engineering technicians, and others.
The design of the turbine housing, for example, involves civil engineers ensuring the concrete structure can handle immense vibration and water pressure, while mechanical engineers determine the optimal placement and alignment of turbines. Neither can work in isolation. Mechanical engineers rely on civil engineers to create structurally sound housing, and civil engineers need input on mechanical tolerances and specifications. Similarly, when routing power cables through the dam, electrical engineers depend on civil engineers to plan conduits within the structure and on mechanical engineers to integrate these pathways with turbine systems. These interdependencies ensure that all components work harmoniously, blending structural integrity, mechanical efficiency, and electrical functionality.
To assess potential environmental impacts, environmental scientists join the team. They assess how changes in water flow could affect local ecosystems, such as fish migration and biodiversity. Their input leads to the design of fish ladders and sediment control systems that mitigate ecological disruptions. Engineers also have legal teams with which they work closely to protect their intellectual property and patent their designs. They help with navigating contracts between engineering firms and electric utilities as well.
This collaboration between engineers and non-engineers ensures the electric dam is not only technically sound, but also environmentally sustainable, showcasing how interdisciplinary teamwork drives innovation with a positive societal impact.
Part 2. Safety measures and fair practices. The project should respect transparency and not involve any type of corruption, seeing how many people it could impact, local communities, ecosystem, and as developers could prioritize technical and economic benefit over social and ethical concerns, it is therefore necessary that the project must have clear measures about only having fair practices. It should be clear in the contracts during the preparation of the project, and the report after having constructed the hydroelectric dam must be detailed about the expenses, the decisions throughout the project, and who makes them. As for safety measures, it is clear that there may be many issues and risks following the construction of the hydroelectric dam. It is the job of the engineers and their teams to see that these risks are all avoided and all the endangering situations should be resolved. All safety regulations must be respected.
Quebec has a large indigenous population of over 182,000 natives. There are historically 10 different nations with distinct traditional borders. These rural indigenous communities rely heavily on the rivers as they have for thousands of years. Building a hydroelectric dam could have drastic effects on these rivers. It could cause mass pollution, especially in the construction process of the dam, negatively impact the migration of fish and species reliant on fish, block access, and damage ceremonial and historical grounds. To ethically and sustainably construct this project, we will have to work with Indigenous communities. Negotiations with the Indigenous communities will be necessary and will impact the location of the site of the dam. We will also have to ensure that the project will not erase any history or destroy ceremonial sites. Also, if the project must be built on fishing grounds, we will have extensive wildlife management involved and ensure that the communities can still access this natural resource. By communicating with the Indigenous peoples before, during, and after the construction of the project, we can foster a healthy relationship with these communities and create an equitable and sustainable project.
The construction of a hydroelectric dam brings significant societal implications, both positive and negative. Let's talk a bit about the impact on society. Hydropower is affordable. It provides low-cost electricity and durability over time compared to other sources of energy. Construction costs can even be mitigated by using pre-existing structures such as bridges, tunnels, and dams already existing in Canada. Hydropower creates jobs in rural locations and boosts local economies. By the way, Canada is the third largest producer of hydroelectricity in the world, employing more than 48,000 people, and there are a growing number of jobs available in hydropower. Reservoirs often support activities like boating, fishing, and camping, generating tourism revenue. Hydroelectric power is also a domestic source of energy, allowing each state to produce its own energy without being reliant on international fuel sources. And finally, hydroelectric power is flexible. Because hydropower plants can generate power to the grid immediately, they provide essential backup power during major electricity outages or disruptions.
Impact on environment. Hydropower is a renewable source of energy. The energy generated through hydropower relies on the water cycle, which is driven by the sun, and is fueled by water, making it a renewable and a clean source of energy. In this way, hydropower development is a great way to reduce carbon emissions, improve energy sufficiency, and minimize waste. Hydropower provides benefits beyond electricity generation by providing flood control, irrigation support, and clean drinking water. But it is also important to be aware of potential negative impacts, such as ecosystem disruption, and loss of biodiversity. To minimize these impacts, hydroelectric dams can be designed more sustainably, incorporating features like fish ladders, sediment management, and adaptive water release to protect ecosystems. Additionally, we need to address the social challenges of reclamation, which could pose significant issues for local communities. Through community engagement and fair compensation, these concerns can be mitigated. However, selecting geologically stable sites and integrating dams with other renewable energy sources can reduce risks and reliance on water flow, helping to prevent dangerous geological impacts.